Hello everyone. Through this video we are going to discuss from question number 12 of exercise 5.2. So here this is exercise 5.2, question number 12. The question is two APs have the same common difference. The same common difference. Putting full stop. The difference between their 100 terms. The difference between their 100 terms is 100. After that, what is given? What is the difference between their 1000 terms? So coming to the solution part, what is given here? Two APs are having the same common difference. So we shall be writing here, let the common difference of both the APs be D. Then after, what is given? The difference between their 100 terms is 100. Difference between their 100 terms is 100. So I shall consider that let the first term of first AP be small a and the first term of the second AP be a dash. Then after, their 100 terms can be written in the way, that means according to question, difference between their 100 terms is given to be 100. So I shall be writing, let us consider that the bigger term is the 100 term of the second AP, say a dash 100 minus a 100. Here a dash 100 is the 100 term of the second AP and a 100 is the 100 term of the first AP. So according to question, their difference is 100. So if I proceed with the general formula, that means formula for a, and what can I write here? A dash plus 100 minus 1 d for the first a dash 100. Then after, for a 100, this will be the first term is a plus again 100 minus 1 d, that is equal to 100. So after this, what do I get? A dash plus 99d. In both the cases, I am using d as a common difference because they are both the APs are having the same common difference d. So after this, minus a minus again 99d, that is equal to 100. So plus 99d minus 99d got cancelled, and I get here a dash minus a is equal to 100. Next, it is our turn to find out the difference between their 1000 terms. So let us come to that part. We can further mark this as expression 1. Now, difference between their 100 terms, difference between the 1000 terms, how can we write it? A dash 1000 minus a 1000. Let us use general formula here. A dash plus 1000 minus 1, then d I can write here using the general formula, and in the later part it will be a plus 1000 minus 1, then d. And then after, what do I get? A dash plus 999d, then minus a minus again 999d. 999d minus 999d got cancelled, and I get back a dash minus a. Now this already we had derived in this expression. You can observe here, in this part we already got that a dash minus a is equal to 100. So this result of course I can use here. So a dash minus a already we got as 100. So I can write here from 1. So this is the required answer. Difference between the 1000 terms is 100. Next, coming to the next number, it is question number 13. So in question number 13, what is given? In question number 13, what do I get? How many 3-digit numbers? How many 3-digit numbers? How many 3-digit numbers are divisible by 7? Are divisible by 7. So coming to the solution part, the 3-digit numbers divisible by 7 we can construct in this way. In series form we can construct like this. The 3-digit numbers, actually in this case it is must that we have to find out the first few terms of, first few 3-digit numbers which are divisible by 7, and the last 3-digit number which is divisible by 7. So the 3-digit numbers divisible, it will be 3-digit numbers divisible by 7 are, the first number could be 105 because 7 15 is 105. The next number could be 112. Then after, the next number is 119, and that goes on. The last number, last 3-digit number before 1000, we can get it to be 994. So in this case here, the first term of course a is equal to 105. Then we get the common difference d as second term minus first term. That means 112 minus 105, the result comes as 7. Yes or no? So we need to find out how many 3-digit numbers are divisible by 7. So in this case, in total we need to find out the number of terms. So I consider here, let the nth term be 994. This implies an is equal to 994. So I can get here the formula a plus n minus 1 d, that is equal to 994. So in place of a, I can put 105 plus n minus 1 d is what, 7, is equal to 994. So after this, 7 into n minus 1, that is equal to 994 minus 105. So what would I get here? N minus 1, 994 minus 105 will give us the result 889, that is divided by 7. So let us check, what do we get when it is divided by 7. 7 1 is 7, then 18, 7 2 is 14, then 749. So here in this case n is equal to 127 plus 1. The result will come as n is equal to 128. Therefore, the required number of terms is equal to 128. Similarly, question number 14 is also of the same kind. Next, coming to I shall come to question number 15 next. For what value of n? For what value of n are the nth terms of the two APs 63, 65, 67, that goes on, and 3, 10, 17, that goes on, equal. So in this case, coming to the solution part, we shall find out the nth terms of both the series separately. For the first series, the first AP is 63, 65, 67, that goes on. Here, first term a is equal to 63, then common difference d is equal to 65 minus 63, that is equal to 2. Then nth term we need to find out. Therefore, the nth term an will be equal to a plus n minus 1 d, and the result comes as an is equal to in place of a I am going to put 63 plus n minus 1, d comes as 2, and then after what do I get? An will be equal to 63 plus twice n minus 2, and then I get an is equal to twice n plus 61. Then we shall keep this in our mind. Okay, means with us, I am going to keep it because it will be required for future use. Then after, the second AP is 3, 10, 17, that goes on. Here, in this case, let us consider the first term to be a dash, that is equal to 3. Then after common difference, let us write down first term a dash equals to this one, then common difference d dash equals to second term minus first term. The result comes as 7. Therefore, I shall try to find out the nth term now. Therefore, the nth term means a dash n, that is equal to a dash plus n minus 1 d dash. In the respective places we put the values. A dash n is equal to a dash is 3 plus n minus 1 d dash is 7, and then after what do I get? A dash n is equal to 3 plus 7n minus 7. So a dash n is equal to 7n minus 4. So these two are the nth terms of the two APs which we get. Now we are given that the nth terms according to question Actually a n is equal to a dash n. That means nth terms of both the series are equal. So here in this case, what do I get? In this case, the first nth term is twice n plus 61. So I am going to write here twice n plus 61, that is equal to 7n minus 4. Actually this result I am putting here in place of a dash n. Then after, what do I get? 61 plus 4 is shifted to the opposite side, and then after 7n minus twice n, and the result comes as 65 is equal to 5n. So what do I get? 5n is equal to 65. Just interchanging the sides, I get here n is equal to 65 by 5, and our answer comes as n is equal to 13. So the 13th term of both the APs are equal. Therefore the 13th terms of both the APs are equal. So this is the required answer. Then next, coming to question number 16. So in question number 16, what is given? Determine the AP. Determine the AP whose third term is 16 and the seventh term exceeds the fifth term by 12. So in the solution part, what do I get? The third term is given to be 16 and the seventh term exceeds the fifth term by 12. So in this case, neither the first term and nor the common difference are given. So in this case, I am going to consider, let the first term be small letter a and the common difference BD. After this, what I shall write according to question? Third term is equal to 16, and then after, what we can write? This implies A3 is equal to 16. That means A plus twice D is equal to 16. So out of this, I can take out value of A in terms of D for future use. Let us mark this as 1. At the same time, the second condition can be utilized. That is what? The seventh term exceeds the fifth term by 12. That means seventh term is equal to fifth term plus 12. Also, seventh term is equal to fifth term plus 12. So what can I write here? A7 is equal to A5 plus 12. Further, A plus 7 minus 1D is equal to A plus 5 minus 1D plus 12. I am using here the general formula. That means formula for A, and I am using here. So after this, what can I write? A on both the sides got cancelled, and I got here 6d is equal to 4d plus 12, and then after 6d minus 4d is equal to 12, and then after twice d is equal to 12 I got, and after that d is equal to 12 by 2. So value of common difference comes as it is 6. Value of common difference comes as 6 because 12 divided by 2 is equal to 6. So this is the answer for common difference. So after this I have to get value of the first term. For getting value of the first term I have to use the first condition, that is a is equal to 16 minus 2d from 1. One implies a equals to 16 minus twice d. Then 16 minus 2 into 6. So 16 minus 12, the answer is 4. So first term is 4 here. Now we have to calculate the terms of this AP, means determine the AP. The AP we have to construct. Therefore the AP is first term, that means A1, we can say A1 is equal to A, that is equal to 4. Then the second term A2 is equal to A plus D, means we can write 4 plus 6 is equal to 10. Then the third term I get here A3 is equal to A plus you can say A1 plus D, A2 plus D, that means 10 plus 6 equals to 16. So in that way these values will go on. Similarly, if we want, we can find out the fourth term also. A4 equals to A3 plus D, and 16 plus 6, that is equal to 22. So the AP is ultimately 4, 10, 16, then after 22, and that goes on, and this is the answer.